Hi everyone and welcome back. Today our topic is measure of dispersion. In this lesson we will learn about three important measure of dispersion: the range, the variance and the standard deviation. Now these measures, that is measure of dispersion, help us understand how spread or scattered our data is. Remember, measure of central tendency, that is mean, median and mode, mostly called average, only tells us about the center of the data. It does not tell us how far the values are from each other or from the center. That is, in the previous lecture, we plot the data here. This was the data. We calculated the center of this. Now, if we want to know that how far each value is from the central value, that is how far is this value, how far is this value, how far is this value, how far is this value from the center, then we use measure of dispersion. Because measure of central tendency does not tell us the distance of each value from the middle value. Only average is not enough to interpret the result. We need some more. For example, two different data sets may have the same mean or the same average, but they may have completely different levels of variability. For example, consider these two data sets, class A test score results and class B test scores result. When you calculate the mean of this data, that is x bar of A, then you will become to know that, suppose let's x bar of A, the sum of these all values is 352 divided by, there are 5 scores or 5 values, so the answer is 70.4. Similarly, when you calculate the mean of this data, that is x bar of class B, so again when you add them all you get 352, and when you divide this 352 on 5, which is the number of observation or number of individuals, then again you get 70.4, meaning that mean for the both of the data sets are same. But when you are asked to which class you are going to be in, so you will definitely select class A to sit in, because the variability among the scores in class B is too high. So students will notice here that class B is widely inconsistent. So class B in this case is widely inconsistent. So measure of dispersion is used to calculate consistency, reliability and stability of our data. Or we need two measures of dispersion to understand the consistency, reliability and stability of our data. So if you see, then class A data is more stable. So the class A students are more consistent as compared to class B students. So let's start. The range. The range, the simplest measure of dispersion. Range is denoted with R, and it is defined as the difference between the maximum value and the minimum value. So I denoted the maximum value with xm and the minimum value with x naught. So this is xm, suppose, and this is x naught, suppose. So range is equal to xm minus x naught. Now let's consider our first example of the two classes scores. Here the mean is 70.4 marks, and here again the mean is 70.4 marks. Now the range here is xm minus x naught. Now the data set, maximum value is 72 and the minimum value is 69, and their difference is 3, which is the range. For class B, the maximum value is 99 and the minimum value is 40, and it gives 59 range, which is quite spread out. Now let's draw the above data sets, or let's plot for range. So this is the first data set, this is the second data set. This is for class A and this is for class B. Okay. Okay, start from 0, suppose, and take differences of 20. Let's guess 20. Next will be 40. Next will be 60. Next will be 80. And then next will be 100. Okay. Now the minimum value is 69. This is x naught, and the maximum value is 72. This is xm. So let's identify the values here. X naught 69. So 69 will be below this 70. The middle value is 70, so this will be here. So just put a dot on x naught. So this is our x naught. Then the maximum value is 72. So 72 is a little bit higher than 70. So this is 72. Suppose this is 72. Now see, this is x naught and this is xm. Now use the same situation here. Now if you plot the same data on this number line, okay, then we get the minimum value is 40. So this is 40. So put a dot here, and then another value is 99. put a dot on 40, and another value is 99, which is here. So now this is x m minus x naught. So this is range for B, range for data set B, and then another one is range for data set A. So you can imagine the spread among these two data sets. Now the biggest limitation of the range is it just takes into account only two values, that is maximum and minimum, and ignore the rest of the values. So to overcome this, we need to introduce the idea of deviation from the mean. A small data is taken, that is 2, 4 and 6, and when you calculate its mean, then it is 4, that is x bar for this data is 4 now. Now take the deviation. Now deviation is the difference between each value from the mean. Like this is the first value, this is x1 suppose, this is x2 suppose, and the third one is x3 suppose, this is suppose x3. Then the deviation may be or can be denoted as d, and the d is the difference of each value from the mean. So let's take x1. This is x1 minus mean, which gives us minus 2. 4 minus 4, that is x2 minus 4 is equal to 0, and then 6 minus 4 is equal to plus 2. When you add them, then you will get, when you take sum of this deviation, then you will get 0, because negative and positive values will cancel out. Now you can draw them as well. Suppose this is our number line, this is 2, this is 3, this is 4, this is, the next one is 5, the next one is 6. So the average value is 4, this is the middle value, this 2 is how far, this 6 is how far from this mean. This is suppose x bar, this line is x bar, and this difference is the deviation of each value from the mean. So here is a value 2, so it's distance from the mean, and another value is 6, so it's distance from the mean. So this is the spread. Now we learned that the sum of the deviation is always equals to 0, so we have to introduce the idea of variance. What variance do? Variance takes the square of the deviation. So when you take the square of the deviation, so the negative signs will automatically becomes positive, and by adding them you will get no 0. Now summation d is actually summation d square, because we took square deviation. So now this is equal to 4 plus 4, 8. Because this minus 2 is 4, then 0 becomes 0, and then plus 2 becomes 4 again. So sum of square deviation is 8 now. Now to find variance, we divide it by n, or n minus 1. Okay, so for the calculation of variance, we introduced the idea of square deviation. So here we have taken the sum of the square deviation, which was 8, and now divide it by n, where n was 3 here, because there were 3 values in this small data set. We can also divide it by n minus 1, but you will learn it in advanced topic. So for in this case, or for the variance, we have divided this 8, which was summation d square, on 3, and the resultant value is approximately 2.67. But now this 2.67 is obtained after taking squares of the values. So when you write a unit with it, then your unit will also be in square. Suppose this is the answer, and if it is 2.67, then whichever or whatever unit is with this data, here in this case it is not mentioned that this data is about what. So here you will write unit, and it will be the unit squared. Suppose the unit is kg, then the answer will be 2.67 kg squared. So squares remove negative and penalizes outliers more, but here we are getting unit square. That is, in answers you have to write unit squares, which is not feasible. So we need to introduce the idea of standard deviation. So standard deviation will help us in return to the original units. That is by taking square root of the variance. When you take square root of the variance, then it will also take the square root of the unit, and this will be a unit alone with it. Suppose if in this case it was kg, then you will write 1.63 kg with it. So standard deviation is the most common measure in statistics. Now let's address the common pitfalls. Okay, so don't confuse variance and standard deviation. Standard deviation is the positive square root of the variance. When you take square root of the variance, you are getting standard deviation. And standard deviation is easy to interpret. So using range when outliers exist, so it will damage the data. For getting units, standard deviation has same units as data, variance has squared units. That is, the answer will be the unit squared in case of variance. But in standard deviation, you will just get a simple unit. Let's summarize our today's lecture. We discussed about measure of dispersion, wherein we discussed about range, variance, and standard deviation. The formula for range was equal to xm minus x naught. The formula for the variance is denoted with s square, capital S square, and it is defined as summation d square divided by n, where I runs from 1 to n. Now this can further be explained as summation D is the deviation of each observation from the mean. So you will take it square. This D is actually xi minus x bar, where I is from 1 to n. Values of x will be changing, but the mean will remain constant because you have to calculate mean from that data. So this is s square is further is equal to n, while standard deviation is denoted with s, the standard deviation, and this is the positive square root of this s square. That is, just take the square root of s square, or you can write it like this: summation x minus x bar whole square divided by n whole square root. Where I run from, okay, well, you write I run from 1 to n here. I run from 1 to n, and this square root is on n as well. But here the units will be in squared, and here the units will be single. There will be no square on the unit. So this is the main difference between variance and standard deviation, and due to this squared unit and simple unit, this standard deviation is mostly used. At the end, let's consider the plot of the two different data sets, that is data set A and data set B from the first example, class A test scores and class B test scores, for which mean were same and was 70.4. So here, if you see in the graph, then the blue is for class, the blue line or the blue color is for class A, the orange color is for class B, and mean is equal to 70.4, which is the middle and the dotted line, vertical line from top to the end. So this is the mean. This is 70.4. This is x bar. This point is x bar. Okay, now the minimum value here, this one is the range for the first data set, and this is the range for the second data set. The minimum value for the second data set was the minimum value for the second data set was 40 and 99. 40 and 99. So this is 40 and this is 99. So this is the range for another one. Now if you see the deviation, so the first deviation is of, here we haven't calculated deviation. Let's calculate the deviation for these two data sets, and the deviation will be having, let's consider these two data sets and calculate deviation. I've used test score of class A, and then I have calculated its deviation. I denoted this with D, and D was is equal to, or D is equal to x minus x bar. So I have subtracted mean from each and every value of this class A test scores. So 70 minus 74, 70.4, then 72 minus 70.4, and so on. First one gives me minus 0.4, and so on. Then I have added another column which is about square deviation. So I have taken square, or I took square of this D column, of this second column, and denoted with square deviation, or D square, and this is equal to x minus x bar whole square. So minus 0.4 squared will become 0.16, 1.6 squared will become 2.56, and so on. Then I added these two columns. The second column, that is only deviation column, gave me 0 as a resultant value, while the square deviation column gave me a value, or decimal value, which is 5.2. Now as we know that x bar is equal to 70.4, then s square is equal to s square, which is the variance, is equal to sum of d square divided by n. In this case it is sum of d square is 5.2, so 5.2, number of students or number of individual is 5, so this is 5. So 5.2 divided by 5 gives me 1.04, but I have to write squared unit with it. Now this is, marks is in score, the unit is score, so I will write score, but with square, because in variance you have to represent the answer with square. Next I will take standard deviation. So standard deviation is represented with capital S, and this is the positive square root of the variance, so this is s square. So what I will do now, I will take 1.04 score square root. So I will get 1.04 square root will give me 1.01, and square will give me only score. So this way I will obtain my original unit back by taking the square root. Similarly, you can do the same calculation for this second data set B, and when you calculate you will get standard deviation is 21.40. so this 21.40, and you write unit with it, so this is score. Now see the differences. There is in class A test score there is too much little difference, meaning that all students have approximately score the same, whereas there is 21.40 differences. Now this difference can be seen from this graph as well. So the distance, the first class A set, which is blue, so the distance is this much. So as one side is the mirror image of the another side, so just define one side first. So this, I have defined this side, and this distance is 1.01. So the other side is also 1.01, and this, the graph became, or the bell curve became too narrow. Now if you consider the class B, where the difference is 21.40, so from this mean you take this much 21.0 distance, 21.40 distance. Okay, so the so the other side, this is now 21.40, so the other side will automatically become 21.40. so you see that set B, our class B8, is widely spread out, and this bell shaped is too flat, while the other bell shaped is too narrow. So smaller variance gives us consistency in the data set, and larger standard deviation or larger variance gives us spread, too much spread in the data set. Hope you got the lecture. So here is the explanation of all the above lecture, the summary. You can check it. Thank you, and see you in the next lecture.